from here. Everson uses a tape measure to measure the diameter and circumference of several circular objects. The table shows these values. Complete the table by writing the ratio of the circumference to the diameter and calculating the approximate value rounded to the nearest hundredth. Okay, so we've got this table and we have 4 different objects. We have a tuna lid, 2-liter bottle, small spice lid, and our portable fan. And we have D and we have C. What's D representing? Diameter. If you want to write that right up here so you remember, you can. Okay, so the D is the diameter. And what's the C representing? Circumference.
And then circumference divided by diameter.
Okay, so C is our circumference. And then it says, complete the table by writing the ratio of the circumference to the diameter. So this right here is the ratio. Circumference to diameter, which also means that we can divide the circumference by the diameter. Circumference divided by diameter. Okay? So on all of these, we're going to do circumference, which is our C. So we're going to have 10.25 over...
You have to line up the decimal.
No, you do not have to line up the decimal.
3.25.
Our diameter is 3.25.
Really all you're doing is dividing.
Okay, yes. On the next one, we're going to set up the ratio. Circumference is what? 12.5 over 4, because that's our diameter.
Are we solving those?
Hold on in a minute. Next one, the circumference is 5.5 over 1.75. And the portable fan, our circumference is 23.5 over the diameter of 7.5. Okay, now, we're not going to work all of these out. Okay, so when you divide, I'll show you on the calculator. This first one, 10.25. 10.25 divided by what?
3.25.
3.25.
Oh, it's now equal.
Okay, so it equals 3.15.
It's 1 over.
1 over. Okay, I have 12.5 divided by 4. On the next one, I get 3.125, and it says to round to the nearest hundredth. So we're going to do 3.13. Is that one close too? Why do you think they're not all super 3.14 accurate?
Because of air.
Because of human error, and it's an approximation, right? It says approximate value. It probably depends on what measuring tool was used, a little bit human error, but it's approximate. The small spice lid, if we divide that, we get 3.14. And the portable fan, if we divide that, we're going to get 3.13. Okay, so in this table,
We got pi.
yes we did. In this table, we had 4 different circular objects. And this person went ahead and measured the diameter of each one of those and the circumference of each one of those. And then when we divide the circumference they got by the diameter, we get close to the value of pi. It's an approximation. Okay? Let me get you to think this way for a second. The circumference of a circle, we can find the circumference of a circle by doing pi times diameter. That's one of your formulas that's in your flashcards. We know the circumference and diameter is here, right? Okay? If I do this diameter of the tuna lid, 3.25, if I do 3.25 times pi, what's the value of pi?
3.14.
3.14. What do you think I'm going to get? I should get 10.25. Okay, so in the calculator, I'm going to do the diameter, 3.25 times 3.14, and I get 10.205. Okay. If they use the actual pi symbol in the calculator, it would get even closer to this right here. Okay. So there's a relationship What's 4? You could even like pretend. What's 4 times 3?
12.
12. Is that close to 12.5?
Yes.
Because we rounded down a little bit, right? Instead of using 3.14, we use 3. This times 3 would be close to 5.5. 7.5 times 3 would be close to 23.5. Okay? So you can kind of look to see if you're going back and forth. Explain how the value of pi is related to Everson's chart. How did Everson get pi? Where does pi come from? The ratio of what? Circumference to diameter is approximately equal to pi. Okay, so in Everson's chart, what we're seeing in Everson's chart, what it wanted you to see and get a pattern for, is that the ratio of the circumference of a circle to its diameter, when you divide circumference by diameter, is approximately pi.
Hey, why is the record button from you?
Did you get this written down?
No.
Okay, write it down.
I don't think so. What? I had a face and she was like, no. Because I don't have a pencil.
Okay, next one. Why do the values for circumference and diameter in Everson's chart vary? Why is it when we divided circumference by diameter, why did the end values vary?
It's an estimate?
Right, it's an approximation or it's an estimate, okay? So we could put an estimate or approximate, let's put estimate, slash approximation. And why is it an estimate or an approximation?
Because it will never be like correct, I guess, because human error.
Right, because of, could be several things. Human error is one of them. Could it also depend on what type of measuring tool you're using?
Yeah.
Okay. There's lots of different measuring tools. You have yardsticks, rulers, meter sticks. I'm sure people that do carpentry work, like flooring and things like that, they've got all kinds of super accurate measuring tools. Okay, you've got the measuring tape like I have that I showed you. Okay, Avery?
Wait, so if you needed to measure the circumference, like, and you had to use a normal ruler,
Mm-hmm.
you could still,
Yeah. If you just had a ruler, you could get like a piece of string and wrap the string around the circumference of something, right? And then cut it and then measure it onto a flat surface. You could do that. Which would even have more human error probably involved than, okay? So there's lots of different ways. You just have to kind of think outside the box.
This whole time I thought
Well, I
you
lived
were
in
saying
Boston.
air instead of air.
Oh, air, like the air you breathe.
yeah, what? I don't think it was.
Okay, number 2. An official hockey puck has a radius of 1.5 inches. Write an equation that can be used to describe C, the circumference of the top of the hockey puck in inches. What shape is a hockey puck?
A circle.
Okay, a hockey puck is a circle.
Wait, so you
Draw it, yeah.
You do C over D.
Hold on. We have a hockey puck. What do we know about the hockey puck?
It's a circle, it has a radius.
The radius is 1.5 inches, and you've got to know your vocabulary. The radius go all the way through or halfway through? Halfway through the center. So the center of the circle out to one outer edge is your radius. And our radius is 1.5. And all this is asking is write an equation that can be used to describe C, the circumference. Who knows the formula to find the circumference of a circle when you are given the radius? Brooklyn.
2 pi r.
Okay, good job. Circumference equals 2 times pi times r.
I don't really like pi.
Draw 2 little lines down, a little squiggly on top. Or just draw a straight line across the top. Okay, so to find the circumference of a circle, when you are given the radius, you're going to use this formula. Because in this formula, what does this r represent?
Radius.
Radius. Okay? So an equation, this is the formula. This is our formula. The equation could be circumference equals 2 times pi, and we want to replace our r
With 1.5.
with 1.5.
So would you replace pi with 3.14?
That's another way we could write it. Let's write it that way too. Circumference equals 2 times 3.14 times, whoops, times 1.5. I don't know. If your phone is on, you need to turn it on silent.
Mine is on you.
All right, so this was our formula, and you need to have that formula memorized. It's on your vocabulary.
Oh, I reached my goal.
So these are equations. These two right here are the equations that could be used to find the circumference of that circle. It's not asking us to solve.
Oh,
On number 3. On number 3, we've got a bicycle tire that has a circumference. What does circumference mean? All around the outside edge of 70 inches. So we know already how far around the bicycle tire it is, right?
Wait, I have a question on number 2.
What?
On where the c equals 2, where did you get the 2?
The 2 is a constant. It's always there because the radius of a circle is half the diameter. So if I know the radius, I can find the diameter, which goes all the way through. By multiplying the radius times 2 will give me the diameter. Okay?
That's on my Everett equation then?
Just this formula. You have to look at your formula chart. Okay? But that's where the 2 is coming from. The radius times 2 gives you diameter.
Oh.
And the relationship between the circumference of a circle and its diameter is what gives us pi. Okay, so we always somehow want to use the diameter when we're dealing with circumference because diameter and circumference have that relationship. Okay? Avery.
Okay, so on number 3, my equation and stuff, so would it be c equals 70 or would you just put 70 equals because
Hold on one second. We're going to write an equation that can be used to describe d, the diameter of the bicycle tire in inches. First thing we need to know is what is our formula to find the circumference of a circle if we're given the diameter. Because now we're talking about diameter, we're not talking about radius. Deshaun? Right. So our formula is c equals pi times d. Okay, Allie? There are 2 different formulas to find the circumference of a circle. This one, which uses the diameter, and this one, which uses the radius. Okay? Do you see the differences in them? Okay. They both have pi, but this one has the radius times 2. When you multiply the radius by 2, you get the diameter. Okay? So they're basically, it's working the same way, only you're doubling the radius, then multiplying by d. Okay? All right, so on this problem on number 3, do we know the circumference of the circle, Avery? Yes, this is what you were confused about, is 70, okay? When you work with formulas, your goal is, this is your recipe, this is what you have to follow. What ingredients do you have? Do you have the ingredient for circumference?
yes.
Yes, it's 70, so we're going to plug that ingredient in. Equals pi d, because we don't know the diameter. It's asking us to find it. If we are finding it, then we don't know what it is.
So that's it.
Okay, so this is one equation. What's another way we could write it?
70 equals 3.14.
3.14 times d. We have the 70 here. What did we do from pi, the pi symbol to here? We just replaced it with the actual value of pi. Okay?
Okay, so then you don't have to put a number for
You don't have, no, we're not solving. There's another way we can write it too.
D.
If we did solve this, if we were solving this right here, what would we have to do?
Divide 3.14 by 70.
Divide 70 by 3.14. We would have to move this over, right? We would divide by 3.14. And when we did that, what would it give us? What would our answer give us?
The diameter.
It would be giving us the diameter. Okay? So another way to write this is D, which is diameter, equals 70 divided by pi, or D equals 70 divided by 3.14. Okay, it's hard to see. D equals 70 divided by pi, and D equals 70 divided by 3.14. Because if we worked this initial equation, if we solved it, that's what we're doing, right? Dividing the circumference by pi to get the diameter. Because to get the pi, we did the circumference divided by the diameter. All right. Number 4. Cameron draws a circle with a diameter of 8 centimeters and calculates the circumference to be 25.12 centimeters. Then Catherine draws a circle with a radius of 1/4 of a centimeter and calculates the circumference to be 1.07 centimeters. Are the calculations for each correct? Justify your answers. Okay, so here we have Cameron. Cameron has a diameter of 8 and a circumference of 25.12. Mm-hmm.
Okay, so no, okay, so then you can use the equation to 25.12 equals 3.14. Or is that?
Well, okay, it's saying are the calculations for each circle correct?
Okay.
So do you know, we know the diameter and we know circumference. Is there a relationship, or is there supposed to be a relationship between the circumference of the circle and its diameter?
Yes.
And what is that supposed to be?
Pi.
It equals pi. C divided by D equals pi. Do we know C?
Yes.
Do we know D?
Yes.
So we can see if these are correct by finding the ratio or solving to see if we get pi. Okay? So to get pi, we have circumference, which is 25.12, divided by diameter, which is 8. Just like on number 1. Correct? We did circumference divided by diameter, and we got pi. That means that that was correct. So if we do, on Cameron, 25.12
It equals pi.
divided by 8, it equals
Pi.
3.14. So do you think that Cameron has the correct measurements?
Yes.
Yes. Okay. So we know Cameron's correct. Cameron's good. Yay, Cameron.
Good job, Candy.
Let's check out Catherine. Catherine has a radius of 1/4 and a circumference of 1.07. What do we have to know in order to see if the relationship between the circumference and diameter is pi?
We turn other fraction into a decimal.
Okay, we can start there. What would 1/4 be as a decimal?
0. Are we trying to find the diameter? Like 0.25.
Okay, so 0.25. This is our radius, though, right?
Yes, ma'am.
How do we find pi? Divide circumference by what?
Diameter.
Diameter. Do we have the diameter?
No, you gotta multiply radius times 2, which is 1/2, and you divide that by the...
Okay, radius times 2 is going to equal the diameter, d, diameter. So our radius is 0.25 times 2 you have 25 cents 2 times, how much money do you now have?
50 cents.
You have 50 cents. So our diameter is 0.50, right? Or 0.5.
That's not right. I don't think, I don't know actually.
Well, what's 50 cents times 3 would be $1.50, which is not going to be quite right. So we're going to take our circumference. We're going to divide our circumference by the diameter. 1.07 divided by 0.5 equals 2.14. Did she measure accurately?
No.
No, or maybe she didn't record it down correctly, right? Because what should she get?
3.14.
3.14.
She's off by 1.
She's off by 1 whole. So are the calculations for each circle correct? No.
Only that one's right.
Did we justify our answer?
Yes. Yes. Yes.
What does justify your answer
Like,
mean?
show your answer. Like,
Prove it. Prove it. I'm proving it because when I divided Cameron's circumference by his diameter, I got 3.14. When I divide Catherine's diameter by her, or her circumference by her diameter, I do not get 3.14, I get 2.14. If she did it correctly, she would have got 3.14 or really, 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 really close. So I'm proving to you that she did it incorrectly. That's my justification. Because pi comes from the circumference of a circle divided by its diameter. She didn't do right. Alright, on the last one. Objects 1, 2, 3, 4. For which object or objects did Roger record the data incorrectly? Explain your answer.
So first we have to set them on circumference over diameter.
Awesome job. So object 1, I'll just put 1, is going to be circumference divided by diameter. Circumference divided by diameter should equal what?
Pi.
The circumference of a circle divided by its diameter should equal pi. If it doesn't, then something's not right. Okay? So on number 1, we have 3.14 divided by 10.
You put 31.4.
Oh, 31.4 divided by 10 is equal to 3.14. Okay, object 2, what would we need to do? What would we need to write down?
7.85 divided by 2.8.
Very good. 7.85 divided by 2.5, circumference divided by diameter.
Does it matter which number's on top?
Yes. Look at this right here.
Circumference.
What has to be on top?
Circumference.
Circumference. What has to be on bottom?
Diameter.
Diameter. Because pi comes from the ratio of a circle's circumference to its diameter. Circumference to diameter, not diameter to circumference. So we get 7.85 divided by 2.5. Object 2 is
Correct.
good to go. Object 3
It's 9.42
divided by 3. Do you think this one's going to be correct?
No. Wait, yes. Yes.
What's 9 divided by 3?
3. Yeah.
7 divided by 2 is also 3 point something. 30 divided by 10 is also 3 point something. Alright. 9.42 divided by 3 equals 3.14. Object 4. What's my ratio need to be written like?
30.69 divided by 9.
Do you, what is, oh.
Just cut.
I know, I was fixing to say, why is it not erasing? So, 30.69 divided by 9. What's 30 divided by 9?
30 divided by 9.
3. Let's say we get 30.69 divided by 9 equals
3.41.
So is all the data did he record any data incorrectly?
Yes.
Which one?
Object 4.
Object 4 equaled 3.41. So incorrectly, yes, object 4.